Hello, first graders. This is Miss Vanderhoff. I know some of you are in my class, but some of you aren't because all of the first grade teachers are going to be sharing some lessons with you. So you're going to see some lessons from me and all the other first grade teachers. And I'm so happy that we're learning together again. I missed you all so much. So I'm going to be teaching you some math this week. And so we're going to have 3 lessons. This is the first one, and we're watching this on Tuesday, I hope. So we're going to be learning about something called graphs. Now, I know my class is familiar with some graphs when we do our weather. We track every day. We look at the window and see what the weather is, and we make our bar graph about weather. So that's a bar graph is a sample of a graph. And the graph we're going to learn today is called an object graph. So our learning target is posted up here. By the end of today, I will be able to understand object graphs and make my own. So I'm going to show you what an object graph is. I'm going to make some with some things I have just around my house. And I'm going to invite you to try to make your own. You can grab anything around your house, maybe with toys, with, I picked some food from my pantry. You could do that too if your parents are okay with it. So I'm going to show you what an object graph is. We'll talk about making one, and then you might make your own today. All right, so I'm going to switch the camera to show you what I found around my house to make an object graph of. So hold on a second. Just a second. All right, we're going to do it this way. Sorry, guys. You know this is all new for us. We're figuring it all out. All right, so I am going to show you this. So you should all be able to see a bunch of cans I have here. And so I just went into my pantry, and I found a bunch of cans, and I pulled them all out here. Now, the reason that people use graphs, and mathematicians and scientists use graphs all the time, and the reason that they do it is it helps them understand information better. So I went into my pantry and said, okay, what kind of food do I have? How much do I have of each one? And when they're all just like stacked up like this, it's kind of hard to tell how much I have. But if I organize it into an object graph, it's going to help me understand how much I have, and I can compare how much there are. And so I have 3 different types of foods here. So this first one is plum tomatoes, and I only have 1 of those. And then I have some black beans. I've got 2 cans of black beans. And then these little ones are tuna, and I have 4 of those. So I'm going to organize these into an object, and what that's going to look like is I'm just going to kind of put them into order. So I'll do my tomatoes first, and I'll put that up here in the top corner. And then I'm going to put the black beans next. So put 1 here, line it up with the tomatoes, and then put the second one here. And then I have my cans of tuna, so I'm going to line those up. And I want to make sure that my rows are even if, because this one's really big and this one's really small, but I want to try to make sure that they're in even rows so I match them up. And here's my second one here, 3rd and 4th. So now, when this information is organized a little more into a graph, it helps us see a little better, wow, I have a lot more tuna than I have of any of my other foods. Now, the last thing that our graph needs, because every good graph needs this, the last thing our graph needs is a title. So I want you to think what I might call this graph. Well, this is all some foods I found, cans of food I found in the pantry. So maybe I'll just call it cans in the pantry. So there we go. Here's my title. And this is my object graph. So I use the actual objects and I organize them into nice, neat rows. And that helps me understand how much I have. And now that it's organized into a graph, I can even do some math problems with it. I can think, well, we can think about which one we have the most of, which one's the greatest. So are you thinking right now which type of can is the greatest? Looks like I have the tuna is the greatest. There's 4 of those. I can think about which type of can is the least. Are you thinking about that? Looks like with only 1, the tomatoes is the least. I could compare. I could say there's more tuna than there are black beans. So there's lots of different math we can do once we have our information organized like this. And we also want to give it a title that helps us understand. Now, there's one more type of object graph I can make with the same information, the same cans. But if I didn't want to put the cans in order, I can also use a bunch of the same object. I'm going to use peanuts because I have a bag of peanuts here, but you might not have peanuts in your house, so you can do it with like Legos, whatever you have that's something small that you have a bunch of. And so if I move these up to the side, and since I'm going to use peanuts, I'm going to have to make some labels. So the first one was tomatoes. So I'm going to make a label for tomatoes. I'm going to put that first. And do you guys remember how many cans of tomatoes I had? So there's just the one. So that's going to tell me how many peanuts to put. I'm going to just put one peanut for 1 can of tomatoes. And then the next one was black beans. Why do you think it's important that I have my labels here now? Because I didn't necessarily need them when I used the cans, but are you thinking why it's important to have some labels? So I had 2 cans of black beans, so I'm going to put 2 peanuts. It's important to have these labels because now that we don't actually have the cans, if we didn't have these labels, I wouldn't really know what those peanuts meant, why they're in different rows. So I really need the labels if I'm going to use all the same thing. But if you're going to use all different things, you don't necessarily need labels. But I could have used labels too for the cans. The last type of can I had was the tuna. So I'm going to make a label for the tuna. And are you remembering how many tuna cans I had? Let's look at them again. So I had 1, 2, 3, and 4. So that's going to tell me how many peanuts to use. Got 1. And again, I want to make sure that they're in even rows. If they're all bunched up, maybe some of them are bunched up and some of them are spread out. See how that's 2 and this is 2, but it doesn't look like the same size. So you really want to make sure you have nice even rows. And I'm going to get 4 tunas. So this is another way to make an object graph to show the same information as when I had those cans lined up. And we can do the same kind of thing. We can see, make sure they're all lined up. We can see that tuna is the greatest. Tomatoes are the least. There's more black beans than there are tomatoes. There's fewer tomatoes than there are tuna. All those different comparisons we could do with the cans, we could do with the peanuts too. All right, so we're going to make another object graph together. With this one, so I told you I found all this stuff just around my house. And you can make them, maybe you have some cans in your pantry too that you can make them with. You can make them with toys you have in your bedroom. You can make it with different colors of crayons. You can make object graphs of anything in your home. So I hope you try out some. So the next thing I have is something else from my kitchen. On the kitchen counter I had some fruits and vegetables. And just like with the cans, when I have them just in a pile like this, it's hard for me to organize the information. I can't really tell if I have a lot of one kind or just a little of the other kind. It's all kind of mixed together. But if I organize it into a graph, it's going to be really clear to me how much of each thing I have and which one I have the most of. So here, I'm going to start with this. So this is a red onion. I'm going to line up my red onions. Start with that in the corner. Here are all the red onions. So I have 3 red onions. And then I have some tomatoes. So next I'm going to line up the tomatoes. And again, just like with the cans, I want to make sure that they're really lined up evenly, even if they're different sizes, so I can really tell very clearly which one I have more of. Next I have some lemons. I'm going to put those. And see, the lemons are really small, but I don't want to put them right next to each other. I want to make sure it's lined up with the row to it. There's my lemons. And then the last thing I have is kiwis. I have 2 kiwis. All right, so here all my fruits and vegetables are lined up. Now the last thing I want to do to turn this in, make it a good graph, is I want to give it a title. So I'm thinking, okay, what would be a good title to describe all these things that I organized. So they're all fruits and vegetables. And I have them on the counter. I don't know if that'll fit on my piece of paper. Maybe I'll just write fruits and vegetables. And I might have to lift up the camera so we can see all of it. But I'm going to write fruits and vegetables. All right. And I'm going to lift up the camera so you can see it with the title. There we go. So I've got all of my fruits and vegetables organized very clearly into my graph. At the very top, I put my title, fruits and vegetables. Now that we have all our information organized, then we can take a look at it and we can really clearly see which one has the most. So are you guys already able to tell what kind of fruit or vegetable is the most? Even though they're small, lemons is the most. There's 4 lemons. And here's a question. Do you see some fruits and vegetables that have an equal number? Which 2 are equal? Are you thinking about which 2 might be equal? I see the tomatoes and the kiwis. They're equal. They both have 2. And there's a few ways that we can tell that they're equal. We can count the number 1, 2, 1, 2. And here on a graph is a really easy way to see things are equal, is a line up here. So see where the tomatoes and the kiwis end? They end at the exact same spot. So that shows me that they're an equal number. We can also do some math problems here. We could think about a math problem like how many more lemons are there than tomatoes? Do you know how we would solve that math problem? How many more lemons are there than tomatoes? Now here's a way that I like to do it. Just like we checked to see that the tomatoes and kiwis were equal, if I want to see how many more lemons there are than tomatoes, I go to where they're equal. So here they're equal, equal. Then it stops being equal because the tomatoes stop, but there's still more lemons. So I can say up to here they're equal. So how many more lemons are there that there aren't tomatoes for? Do you know the number? 2. So there's 2 more lemons than tomatoes. And I can also do this like a math problem. I could say that there's 4 lemons, so 4. And if I take away the tomatoes, minus 2, that's going to tell me how many more there are. So 4 minus 2 equals 2. That gave us the same answer. So there's a couple different ways to solve these kind of questions. I know they're kind of tricky, the how many more than kind of questions. But it's easy to see on a graph because you can go until they're equal and then see how many left over there are. Or you can take the bigger one and take away the smaller one, and that will, whatever is left is going to tell you the difference. Now, just like I did with the cans, I could also build this exact same graph with the same object. I could do it with the peanuts again. I'd have to make my labels like before. So in fact, I'm going to leave them up here until I replace them. So the first one was onions. So I'm going to make a label for onions. So here's our onions. And we see 1, 2, 3 onions. So I'm going to take those onions away and replace them with an equal number of peanuts. So I'm going to get 1, 2, 3 peanuts. Then we have some tomatoes. In fact, I already have the word tomatoes before, so I'm just going to use it again. Tomatoes. We see 2 tomatoes. So I'm going to take those 2 tomatoes away and replace them with 2 peanuts. And like I said, the reason I'm using peanuts is it's just something I had on the table. But if you might use any other object. It doesn't matter what it is as long as you have a couple of the same things. Next we have some lemons. So I'm going to write lemons. And we have 1, 2, 3, 4 lemons. So I'm going to replace those with 4 peanuts. And just like everything, I want to make sure they line up really nicely so I can really clearly see how they compare. Because look, if these ones are all squished together, it looks like it's the same amount as the onions, but we know it's not true. There's 2, 3, here's 1, 2, 3, 4. So you want to make sure they're all spaced out evenly, so it's really clear which one has more. The last thing is kiwis. So I'm going to write kiwis here. And put that right there. And there's 2 kiwis. So I'm going to replace that with 2 peanuts. And the information here is the exact same information. Let me move it up so you can see the title too. The information we have here is the exact same information as we had when we had the actual fruits and vegetables. These peanuts just stand in place of the actual fruits and vegetables now. But we can still see tomatoes and kiwis. They're still equal, 2 and 2. There's still 2 more lemons than there were tomatoes. We can see that lemons has the most. We can see that tomatoes and kiwis are tied for the least. So this is all the kind of information we can figure out when we see information presented in graphs like this. All right, we're going to do one more graph together. And this is with something that you probably have around your house. So I just went into my wallet and I found some coins. I bet you probably have some coins around the house too. So if you wanted, you can make this exact same type of graph with the coins. Now, you might not have the same number of coins that I have, but that's just fine. Just take what you have and you can organize to a graph just like mine. So right now, just like before, when it's in a pile like this, we can't really tell how much we have. We can't really tell which kind of type of coin we have the most of. That's why it helps to organize it into a graph. So I have my quarters. I'm going to organize all my quarters in a row. Here I can zoom in a little bit since it's small. No, it's a little better. Okay, so we have our quarters. Let me find all the quarters. Okay, those ones are all quarters. And then I have some dimes. And then we have nickels. And pennies. All right, so I have all my coins organized here, and now I can really clearly see which type I have the most. So my question to you, which type of coin do I have the most of? Are you thinking about which one is the most? Looks like quarters has the most. I have 1, 2, 3, 4, 5 quarters. And I'm going to make sure they're all lined up just like I said, so it's really clear to see. Which type of coin do I have least of? Which type of coin is the least? It's like nickels are the least. And then I see an equal number of 2 coins. Do you see the equal number? So dimes and pennies are equal. Now you know there's one more thing I need to add to my graph, and that is a title. All good graphs should have a title. So I'm just going to call this one maybe coins in my wallet. Coins in my wallet. There's my title. And since it is good to label things, even though you kind of know what all these things are, but I could still make my labels. So here are quarters. And here we have dimes. And nickels. Let me just spread them out a little bit. Nickels, oh, you can't see that. Here we go. Nickels and pennies. Okay, and there we have it. So here is an object graph that shows the coins that I had in my wallet. We have a title for it that tells us what this graph is all about. We labeled all the different things we're counting, and when we see it all organized in nice rows, it's really clear to see how many of each type we have, and that helps us solve those questions. Now let's do one more of those types of questions, the question where we ask, how many more of one thing do we have than how many more of one thing do we have than something else? So I'll ask this question about dimes and nickels. So my question is going to be, how many more dimes do I have than nickels? So take a look at the dimes, take a look at the nickels. Remember, there's two different ways that we solve problems like this. You might do it like this. You might say, all right, so here is where nickels end. So here's where they're equal. On this side, they're equal. And on this side, we have some extra. So we can do it that way and say here they're equal. And then after that, there's two more dimes. So that tells me there's two more dimes and nickels. That's telling me that that's the same problem as we had on the other one. Let's do it with quarters and nickels then. How many more quarters do we have than nickels? So again, two different ways we could solve it. We can go until when nickels ends and cut it off and see how many more quarters are on the other side. So how many more quarters on the other side of my hand? 1, 2, 3. So that's telling me there's 3 more quarters than nickels. And we can also do it with a subtraction problem. So we can say there's 5 quarters and there's 2 nickels. So we're going to take away the nickels and see how many are left. So 5 minus 2 is 3. That's the same answer we got. There's also one more way that we can do these kind of problems. We could also think of it like this. We could say we start with the nickels, 2 nickels, and think, how many more nickels would I need to add to be equal to the number of quarters? So that would look like this. 2 already, plus how many more? We don't know how many more yet. 2 plus what is going to be equal to the number of quarters, which is 5. So 2 plus what equals 5. So we'd have to think, here we have 2, 3, 4, 5. How many more nickels do we need to add? We need to add 3 more nickels. So any of the 3 ways that we tried, it's going to give us the same answer. Either we cut off where the nickels and quarters are the same and count how many extra quarters there are, 1, 2, 3. We can subtract, start with 5 quarters and take away the 2 nickels and what's left. That gives us 3. Or we could start with the nickels and say, count on until you get to the number of quarters. How many times do we have to count on? And that also gives us 3. So 3 different ways to solve those type of problems. Now, so I hope you know now a little bit about what object graphs are, how to make them. They're easy to make with things around your house. So I hope, my challenge to you is that I hope that you find some things around your house, maybe some cans in the kitchen like I found, or some fruits and vegetables off the counter, maybe some coins in your wallet, some Legos, some toys, some books, whatever you have around the house. I hope that you organize them into an object graph. Get a little piece of paper and write a title for it. Maybe you can label the sides like I did to label what the different things are. And if you want, take a picture of it and send it to me because I would love to see the object graphs you guys come up with. I hope you guys try it out. I will see you tomorrow. Tomorrow we're going to be making some picture graphs. I'll see you then.